Okay, so flip that over and let's take a look at example 3. We want to factor 3x squared minus 9x plus 12. This is a trinomial. We want to factor what's common in all three out. So look at all three of them and decide what number can come out of all three of them. I can divide 3 by 3, I can divide 9 by 3, and I can divide 12 by 3 evenly. So my GCF, in this case, is at least 3. This has x squared. This has x. This doesn't have any x's. I cannot factor out, I cannot common factor out an x from all three. So what that means is I'm left with common factoring out of 3. So 3x squared divided by 3 is x squared. 9x divided by 3 is negative 3x. That negative follows. And 12 divided by 3 is 4. And that, ladies and gentlemen, is what we have when we common factor out the 3. We can expand it to see if it works. It'll give us 3x squared minus 9x plus 12. It is correct. Pretty simple stuff once you get the handle of it. Example 4. The liner notes from a CD form an area represented by this binomial. Write an expression for the dimensions of the liner note by factoring its area. Well, I think the first thing we have to know that a liner note for the inside of a CD is a rectangle. It's pretty close to a square, but it is a rectangle. So there's my liner note. You know what I'm talking about, right? I'm talking about the piece of paper that's inside your CD case. It's the thing that you pull out and maybe it'll have lyrics on it or what have you. Those are called your liner notes of the CD. So the CD case. So we have an area here of 12x plus 3x squared. That's the area. But we want to break that up into length times width. Because it's a rectangle, we know that the area will be length times width. So what would be nice is if I could factor this. This is just like what we were doing with difference of squares, only it's a different type of factoring. So what type of factoring can we do here? Is this a difference of squares? No, it's not. But is there a type of factoring we can do? Well, is there anything in common? There is. I can common factor out of 3, and I can common factor out an x. So I take the 3x out, and it leaves me with 12 divided by 3, which is 4, x divided by x, which is no more x's, 3 divided by 3, which is no more number, it's actually a 1, and x squared divided by x is x. And that leaves me with a factored form. Now, this is perfectly fine. It looks a little weird, though. This is a nicer way to write it. We like to have, if the x is positive and the number's positive, you might as well put the x in front. And what this means is, since area equals length times width, one of them can be our area, and one of them can be our length, and the other one can be our width. And that's what we've done here. So one of them can be our length, and the other one can be our width. And it doesn't really matter which is which. So it said calculate or write an expression for the dimensions. So length is equal to 3x units, and width is equal to x plus 4 units. So now it says find the actual dimensions if x equals 6. Well, all right. So what we knew is that we knew that length in terms of x was equal to 3x. So now they want to know length in terms of 6 for x. That's what they're telling you. So it'll be 3 times 6, 18 units. Well, not even units. They tell me the units, so it's centimeters. 18 centimeters. And the width, in terms of x, was x plus 4. So if they're now going to tell me that x equals 6, it's going to be 6 plus 4. It's going to be 10 centimeters. So what we have is a liner note that's 18 centimeters by 10 centimeters. C, determine an algebraic expression for the perimeter. It wants an expression, so not numbers. So your liner note looks like this, 3x, x plus 4. So if we're going to do the perimeter, it's going to be this length, plus this length, plus this length, plus this length, because perimeter equals the distance around the object. So it's going to be 3x. Oh, I need more room. So the perimeter is going to be 3x plus x plus 4 plus 3x plus x plus 4. Then we're going to put those together because we want a simplified expression. 3x plus 3x is 6x, 7x, 8x. So that's going to give us 8x plus 8 centimeters. And that is an expression for the perimeter around the outside of this thing. Using the perimeter, find the actual perimeter using the dimensions from part B. I think we did that already. Find the perimeter, determine an algebraic expression for the perimeter. We've done C and D all in one step. Check your answer. Oh, hold on. No, I know what they want now. If we know that the length is 18, and if we know that the width is 10, then its perimeter should be 18 plus 10 plus 18 plus 10, which will be 28 plus 28 is 56 centimeters. They want us to check that if the perimeter, if the dimension is 6, that it works out to be 56. So 6 times 8 is 48. And of course it works out to be the same. So it doesn't matter whether I use this formula or whether or not I use the dimensions that we worked out. And check your answer by substituting x equals 6 into part C. That's what we did right here. All right, that's it for common factoring. That's pretty quick. We've got some questions here for you to do. So in your textbook, page 289, 1, 2, 3, 5, 6, 7, 8, and 9. Get those done and we'll be back with starting trinomial factoring.